everyone, I am Khondokar Said Ahmed and I am presenting you an electric charge and Coulomb's law. First of all, I will show what is the electric charge. The electric charge is in between the positive and negativity, as it's acting as a particle of metal bodies, and matter is made of atom. Inside an atom there is the nucleus that is surrounded by electrons as you see in the figure. Here is you can see inside the nucleus there are two particles. First is called proton and second one is neutron. The smallest nucleus contains only one proton, as you see in the figure in this part, which is angstrom as in the symbolic way. The nucleus inside is a hydrogen atom. What you see in this figure is example of a hydrogen atom, hydrogen nucleus. Proton and electron attract each other. Proton and proton, electron and electron repel each other. This is a property of these matters, as you see proton and electron, and we call it as charge. The whole structure is in this picture is an example of charge. The electron charge is a property of matter that can cause attention and repulsion. We call the charge claimed by electrons, and its negativity showed as -e, and the charge carried by proton is positive, +e. Charge is a value or a scalar, not a vector. It's fully described by a number. The unit of charge. The unit of charge is coulomb. An electron or proton has a charge magnitude as E equal to 1.60818 into 10 inverse 19 coulomb. Some scientists and chemists is particular use another unit, the USC, and electronic unit 1 equal 3.3564 into 10 inverse 10 coulomb. No one has ever seen the charge, but we sure all see its effects in everyday life. Electronics discharged in dry winter, days to coal applications. The powered by electricity. Now, what you can see, and what do you think? How much more do we know about the charge? It's all referenced by the International Systems of Unit. As you see, here is the link of this reference. And next slide I will show examples of charges activities. Charge and charge up. Here you can see a cloth and a metallic body, and we created a charge in between two parts. In the demo, we wrap in electrons to make an object positivity and negativity charged. There are many ways to charge up an object. When there are not, we call it charged. In the next slide, the observation of electric charge. The electric charge, as you see in this figure, oxygen 21 and neon 21 all is in a nucleus, and here is an equation like 8 equal to 10 plus minus 2. It means 8. Charge can move between objects in the system, but net charge of systems remain unchanged. Charge cannot be created or destroyed in the system because charge is just property of electrons and protons. Both are matter and matter conserves. And the next slide, as you see in the example in the previous slide, there is a charge in matter in 4 ways. First of all, you can see a conductor way, an insulator way, to ground and the ground. To the ground, charge flow from charged object to the ground, leaving object neutral. And for the ground, a neutral object that can accept or supply an initiality unlimited number or charges. Here you can see this pictures in 4 metric way. Then there are more example in these pictures. First of all, a rubber is hanging up a glass and it shows its charges vectoric way and its numeric way. And then there are more example of force between charge and charge interaction. Then here is an example and equation of Coulomb's law. Coulomb's is the unitic systems of charge. In this equation you can see F equal to K, Q, Q1, Q2 and R square. And the value of K is a constant in this process. And the value of K is 1 by 4 pi epsilon naught. And here F is a 4, Q2 experience becomes of Q1. As you see in this process, and then R is the unit vector directed from Q1 and Q2. Then K is the Coulomb constant, as I said earlier. The value of K is 8.9876 into 10 to the power 9 Newton meter square inverse Coulomb square, and its value is 1 by 4 pi epsilon naught. And epsilon naught is a primitive of free space. Epsilon naught value is 8.8452 into 10 inverse 12 Coulomb square by Newton inverse meter square. And then I will discuss about Coulomb's law. The term point charge refers to a particle of zero size that carries an electric charge. And then next part will be the force is invisible, potential to square of separation R between the charge and directly along of the joining them. The electric force of a Newton's third law. Opposite reaction. The force of Q1 is equal magnitude and opposite in direction to the force on Q2. As you see in this figure. In this figure, with like signs of the charges product Q1, Q2 is positive and the force is repulsive. With unlike signs of charges, the product of Q1 and Q2 is negative and the force is attractive. And here is some templates for the solution of Coulomb's law. Step 1. Formulas of related and concept known as quantities. Third step will be direct and application of formulas, concept or condition to form an equation. Fourth step, factor involvement. Fifth steps, unit the final answer contract. Answered all were asked. As you see in this example, in this part, obviously first part will be separated with the Coulomb's law. Here is, you can see this Coulomb's law. Second part known as quantity. What you have this process as Q1 and Q2 or Q3, whatever you have, you can process in this equation. The third part, direct application of the formulas twice. The all values of Q1, Q2, R or F or K will be implemented in this part. Then part is it vector or something else? The next part will be unit as answered. You can see this. Yes, this answer is given in vector form, and next part will be answered as yes. SI is used unit Newton. There's the electronic charge and Coulomb's laws in a simple form and its simplification. Thank you all.